Hey Algebra, quick video for you guys. These are the practice problems I projected at the end of class on Friday. If you didn't do so well on either of the last two quizzes, this is your ticket to do the retake. You need to bring these problems in solved to me. And then I'll have a retake quiz ready for you on Thursday. I won't be in class on Tuesday, but you will get the test review and the chance to work on that review. And then we'll take the test on Wednesday. I'll also be sure that on Tuesday you get all of your quizzes back so you can use those to study as well. So as far as I can tell, mistakes on this topic are coming from confusion over the rules between addition and multiplication. So when we were adding together different polynomials or monomials, I was very clear that an x to the fifth should not be combined with an x to the third. Under multiplication, however, the rules are different. In this case, we can multiply the 3 and the 2, the coefficients, to get 6, and then add the exponents together to get x to the 8th. Now remember, the reason this works, if you check your notes, is because x to the 5th is x times x times x times x. And x to the third is x times x times x. So look, how many times have you multiplied x by itself? 1, 2, 3, 4, 5, 6, 7, 8. That's why adding the exponent works. It also explains why, in the case of raising powers to powers, you multiply the exponents. If there's any distribution going on, it's here. This 3 in the exponent's position is acting on both the 3 inside the parentheses and the x to the 5th inside the parentheses. 3 to the third is 27, and x to the 5th to the third is the same as x to the 15th. And again, why is this so? Well, x to the 5th is really x times x times x times x times x. But it's been raised to the third power, so that happens 3 times. And how many x's do you have total? 5, 10, 15, 3 groups of 5, or 3 times 5, for x to the 15th power. Finally, I know many of you are asking why this statement is not correct. Aren't you supposed to distribute the 3? The answer is no, because these numbers, 3, x to the 5th, and y to the 10th, are all being multiplied together. If x to the 5th and y to the 10th were being added, we would use the rules of distribution for addition to get 3x to the 5th plus 3y to the 10th. But when we multiply, everything is already multiplied by everything else. The x to the 5th is multiplying both the y to the 10th and the 3. The 3 is multiplying both the x to the 5th and the y to the 10th. The y to the 10th is multiplying both the 3 and the x to the 5th. No distribution is necessary. Were there a coefficient inside, you could multiply the 3 and the 2 because that simplifies to 6. The 6 is multiplying both the x to the 5th and the y to the 10th because multiplication is commutative. Double check the notes we did on Thursday, especially the second page about powers to the powers. I'll do one last example to try and make this more clear. Suppose for a moment you had a monomial raised to a very large power, like 50. Rather than multiplying everything out, we can use exponential notation to write the value of the number in a simpler form. 2 times 2 raised to the 50th times x raised to the 100th times y raised to the 100th. Now, ask yourself, how many x's do you have? Well, it's right there, 100. How many y's do you have? 100 also. But how many 2's do you have? Well, there's 50 right here, and there's a 2 to the first power right here. And what do we do when we multiply numbers with the same base? We add the exponents. So that's 2 to the 51st power times x to the 100th times y to the 100th. Maybe it'll be more clear if we had 2 to the 20th power times 2 to the 50th times x to the 100th times y to the 100th. You do the same thing with the 2's that you do with the x's and the y's. When you multiply together anything by the same base, the base here being 2, you add the exponents. 2 to the 70 equals x to the 100 times y to the 100, which is usually just written without the dots. Now, of course, I haven't made you multiply anything that large, but the principle is the same. 2 raised to the 3rd power, 2 times 3, so x raised to and y raised to the 6th power. But with a smaller exponent, it's easier to assign a value. 2 to the 3rd is 8, times x to the 6th, y to the 6th. And now we multiply the coefficients only, for a total of 16, x to the 6th, y to the 6th. I think it's helpful to think of the x and y's as the name of the term. What type of term is this? It's an x to the 6th, y to the 6th term. Or the name of the monomial. What type of monomial is this? It's the type with x to the 6th times y to the 6th. And how many of those terms do we have? 16, the coefficient. I hope this has been helpful. Please do the practice problems at the beginning if you want to come and retake your quiz. And as an incentive to be sure you're ready for your test, if you made an okay grade on the quiz, or above a 70, so a retake won't do you any good, I'll accept these problems in place of one of your Think Through math lessons. In other words, I'll give you 20 points in your participation grade. Enjoy the rest of your weekend.